Welcome to Brainstorm 9000.
You got a brain? Your brain wants to listen to this podcast.
So open your brain.
Hello, Internet, and everybody else who is still listening to this podcast that we lovingly call Brainstorm 9000. Today, I'm alone here without Hermes, who is still in the mountains of Olympus doing very important stuff during probably the summer break in New York City. But actually, I'm not alone because I have two interesting guests here. Maybe you guys can introduce yourself.
Sure. I'm Jason Nichols. I am the Director of AI R&D for Walmart's Intelligent Retail Lab.
Sounds scary. And you?
I'm Julian. I am a computer vision engineer, and I work on Jason's team.
Computer vision means you teach computers how to see,
Yeah, see, understand, and process.
like Fei Li.
Very similar.
Really?
I mean, it's a bit of an honor to be compared, but
So let's remind people who Fei Li is. I specifically decided to do a search on how many females are famous in the field of artificial intelligence. And Fei Li came up first. Her achievements are many. Let's start from the fact that she teaches, I guess, at Stanford, right? She has a PhD in computer science, and she was instrumental in developing new technological approaches to image recognition, right? Or how do you call it in your parlance?
that was image recognition is correct.
Right.
Classification and recognition.
So then I went on and viewed her presentation on TED Talks. And then I also saw her being interviewed on numerous occasions. So now I know who she is. And what I hear and see is kind of scary. Maybe today we can talk about how existing so-called narrow artificial intelligence or just artificial intelligence affects our lives. I would like to remind our listeners who probably listened to already many episodes of artificial intelligence that I've done since I met with you guys first. By the way, your episode is the most listened to, the original one. So people might want to go and take a listen again. Only on YouTube, it's about 8,000 hits. One of the things that seem to be concerning is that the majority of people still don't know much about artificial intelligence. They know that it's there, right? And people frequently use Siri, and Siri frequently talks to us. Hey, Siri. Hey, Siri. What is artificial intelligence?
In computer science, artificial intelligence, sometimes called machine intelligence, is intelligence demonstrated by machines, in contrast to the natural intelligence displayed by humans. Do you want me to keep reading?
No. Hey, Siri. Are you intelligent?
I'm smart enough to know not to answer that question.
So this is a sample which is very impressive, but it's an example of narrow artificial intelligence, right?
Absolutely.
And then there is,
It's good at giving pre-programmed responses
right,
that are mildly witty.
yeah, meaning somebody took the time to sit down and write all these responses and write algorithms.
So it's not all the responses, but Siri uses what's called a Markov chain or
Right.
a Markov model to choose randomly from certain outputs in a set.
Right.
She does more than that. And I want to make sure that I'm not diminishing the capabilities of the system. But the way Siri works is that for many chosen inputs, she has a small group of select responses that she can give.
Right.
So that if you ask her the same question, you'll usually get the same response, but for some, you'll get some slight variation where she'll pick from a list of 3 phrases or 4 phrases. But that's not the same as what you asked the first time.
Right.
So when you ask her the first time, she was actually looking something up. So it was using speech to text and then a web search to try and find you the text. And then it was using text to speech to convert it back again so that she could talk to you. When you asked her the second time, that's when it was a Markov chain where she was choosing from one of these small groups that answers that she has.
So what scares me in this entire conversation is that it's very technical, but you refer to Siri as she, and it's actually a bot, right? Or no?
I mean, it's a type of chatbot, but when you start to talk about a bot, you mask a lot of the complexity. Siri's not a bot in the sense that like Rosie from the Jetsons is a robot. She's not a single contained physical entity that you could point to and be like, that's Siri.
Right.
She's a suite of computer programs operating all over the world on various different servers, doing a host of different tasks that all come together to produce the result and the illusion of a single entity.
Right.
But there is no Siri that you could touch or point to or really interact with other than through these, what we call APIs, application programmable interfaces, where we can send some information to another program and get it back. But she doesn't live in your phone. But we use she as a colloquialism because the voice is female.
Right. Do you know why they chose a female voice over the male voice?
Less threatening.
Yes. As somebody who knows psychology, I know. Do you agree?
Yeah.
Okay. So let's see whether Siri knows someone else. Hey, Siri. Who is Sophia?
Which one? Sophia PTN, Sophia Woodruff, Sophia Gonzalo, Sophia Zell, Sophia Bakken, or Sophia PTN.
Sophia the robot.
What would you like to know about Sophia Zell?
What is she capable of?
Okay, I found this on the web for what is it capable of. Check it out.
Siri's having a slow day.
So, none of the abbreviations that she gave means anything to anybody. These are all entities coded on my cell phone.
I believe, so Sophia, the one you were referring to, is the Saudi Arabian citizen who's a robot?
Yes. Have you ever met her yet?
I have never met her. I'm sure she's very charming.
I actually don't know anything about her. I think briefly I might have seen the news or a headline, but this is new to me. So.
Well, actually, one of the computer creating companies, right? Software companies probably, created this robot who looks like a female with blue eyes, but you can tell it's a robot because you can see through the transparent part of the head that there is something there. And this thing gives speeches and kind of plays a human, right?
That's my understanding. I haven't actually seen Sophia in action.
Right.
I mean, based off what you're saying, I assumed originally she was like a PR stunt.
Right. Probably.
Yeah.
I still assume that, to be honest.
Yeah. I'd be very interested to see what speeches she's giving.
Well, you can YouTube her.
Yeah.
It or whatever. I don't know. Them. How about that? So I think for a middle-of-the-road person who lives in the modern world and kind of follows AI, a couple of events have been kind of scary. So what really started off my interest, and now I'm extremely interested, is me listening to the interview that Elon Musk gave to Joe Rogan. And you can on YouTube actually single out a 26-minute plus a few seconds part where he talks specifically about his concerns about AI. And the concern is that once it becomes general AI, which basically is a term for artificial intelligence reaching the point when it's like us, and then builds almost instantaneously, I'm guessing, super intelligent AI, which is way beyond. This is all theory. Then we are screwed because it might decide that it either doesn't need us at all, or can use that or could use us as a source of energy, or maybe just burn us because we are ridiculous. I mean, we don't know what's going to happen. And then I looked, and it turns out there are many things that are already going on. You don't need to wait for general AI. Like, for example, ambient computing.
Mm-hmm.
Could you explain what it is?
So ambient computing is a kind of general term, but it applies to the idea that there is some level of compute ability constantly surrounding you. So
Right.
everything that you're carrying or wearing has some degree of intelligence. So if you wear headphones,
I have an
smartphones,
iWatch.
the Apple Watch, you have the Apple Watch. If you had ear pods.
Right.
Or Google has a great product for their earbud that can actually translate what you're saying in real time.
Seriously.
Yeah, absolutely. And so every piece of electronics that you have has some compute capability embedded into it. And the idea behind ambient computing is that you can create this computational fabric where these devices can communicate with each other, and then they can create something that's greater than the sum of their parts. There was a great Kickstarter recently, a couple of years back now, on a compute device that consisted of several components, but the device itself really was the sum of those components. So it was a slate that was like your tablet.
Right.
There was a smaller slate that was the phone. The actual brains of the device primarily lived in the watch. And then it had earbuds, and I forget what the other components were, but they all had computational ability. They all had some level of processing power inside them. They all communicated with each other over time so that when you picked up your tablet, you could see the same thing that had been on your phone because the state was saved in your watch and could be communicated to all the devices. And you could easily transmit back and forth between them. I wish I could remember the name of the program now. It was a fantastic Kickstarter that they had. But it actually sadly never came to fruition. The marketing was much better than the engineering behind it.
Yeah, but I can tell you that, for example, I have an iPhone, and I have a watch, and I have an iPad, and I have an Apple laptop. They all talk to each other. I mean, if I did something on one, the other one knows about it right away. And it's not even a secret, like everybody knows.
Well, so that's the thing. The difference there is that the way the Apple devices work, except for the watch and the earbuds,
Right.
They actually don't talk to each other.
Right.
They have to talk back to Apple. And so they all talk to a centralized server as opposed to having a conversation with each other. And the idea behind ambient compute is that you can cut out that middleman,
Right.
and they can just directly communicate with each other. So like right now you use Bluetooth for your earbuds to talk to your
Right.
phone and for your watch to talk to your phone.
Right.
But the hope for ambient computing in the future was that everything would be able to talk to the things around it, as opposed to in today's model of what we call like a hub and spoke internet.
Right.
They have to communicate up to the central server owned by this company, which is where you get these big privacy concerns and the data leaks and whatnot, is that everything has to go out of your house
Right.
into some faraway data center, usually many data centers where it's replicated, and you lose control over it. It goes outside of your sphere. But with proper ambient computing and with a computational fabric, if your toaster needed to know, or it needed to let Amazon know that you were out of bread or something, your
Right.
fridge needed to tell something, all the devices in your home could talk to each other instead of having to go out of your house, leave a message on a mailbox somewhere else,
Right.
and then wait for the device next door or in the same room even to pick that message up, which is what they're doing today.
How different is it from the Internet of Things? That's another term I learned.
So
They're connected, right?
IoT is the first, or the counterpoint to ambient compute. IoT is the idea that everything connects to the internet.
Right. Internet of Things.
Exactly. So all of your things have messaging to the servers,
Right.
and then they can all talk to the same servers or different servers. They can leave messages behind for each other. Ambient computing cuts that out entirely and says, instead of talking to the server,
Right.
talk to the refrigerator. Go direct one-to-one communication, and disintermediation is the key.
Scary stuff. So I told you that I'm going to talk about a particular story. So I'm going to tell you the story. So a few weeks ago, a young woman told me the story that while at home alone in her kitchen, where she had only herself and her iPhone sitting next to her, she was wrapping a sandwich into a glad, transparent wrap. So she wrapped it, put it away into her refrigerator, which is not a smart refrigerator, just a regular refrigerator, and then went to Google something and immediately had a Glad transparent wrap commercial pop up. So they listen to us, these things?
Well, smart devices definitely listen to us, and they have to be able to do what you just demonstrated.
Right.
For Siri to be able to respond, she has to wait for that key phrase, or she won't be able to respond.
Right.
But they're not listening to the sound of your plastic wrap and inferring the brand.
Right.
So a lot of that comes from the amount of data, the massive amount of personal data that we kind of leak onto the internet every day.
Right.
So if this lady, obviously she bought this plastic wrap, I assume she didn't steal it.
Right.
So there's going to be a purchase history that's tied to her identity somewhere. Let's say she went to CVS or any retailer. I don't want to name a specific one as an example, but to any retailer, and she used their, either if she paid with a credit card or if she used a loyalty card,
Right.
there's a purchase history that's associated with her identity. And now advertisers really want to target people who are likely to buy their product. So one of the things they might look for in a profile is someone with a purchase history for Glad.
Right.
And then the fact that she saw it is actually a great example of something called the Bader-Meinhof effect, which we were speaking about just before.
Yes. Would you tell us, is it 2 people, 1 person? How many people?
So I mistakenly thought it was named after 2 people. It's apparently named after the Bader-Meinhof group.
So many people.
So many people.
Right.
But it's a combination, or actually to quote from Wikipedia, Arnold Zwicky suggested that the phenomenon is the result of the combined action of 2 cognitive biases, selective attention and confirmation bias. So what that means is that you become primed to see the thing that you've already seen. That's your selective attention.
Right.
And then because you believe now that it's important, you
Right.
see this confirmation bias. She may have seen 20 commercials for Glad the week before,
Right.
but she didn't associate them with the Glad wrapping that she was doing at that moment.
Right.
And so suddenly now it becomes a significant event in her mind that, oh, I had this in my hand. I see an ad. The 2 things must be related. Clearly, this is some kind of signal or sign.
Yeah.
Yeah, and she just got 10 other ads for things that she wasn't associated with and didn't even consider.
Right. And this, to your point earlier about the ambient computing, we're constantly bombarded with these ads on all of our devices and all of our platforms, and they just don't matter. They fade into background noise. We don't pay attention to them anymore.
Correct.
Unless we do. And then when we have this reason, now all of a sudden there's one ad in this sea of noise.
Right.
I mean, I don't know about you, but I play a couple of mobile games on my phone, and
I
there's
don't.
ads on there. I Google for things periodically, regularly.
Right.
There's ads there. I listen to Pandora sometimes, and I get ads, or
Right.
I watch TV and I get ads. And I just ignore them all. And it's only when one of them seems significant that
Right.
it stands out in our head, and we go, oh, wow, man, Google's listening right in on this conversation. Managed to figure out what brand of plastic wrap I use based solely on the sound of me opening this box. It's a little more pedestrian usually.
I have to tell you that, for example, I would like to talk in connection to that about one particular person who is an influencer, as they say now, and who actually makes me think even more about awful things that are connected to the internet. So I'm going to invite Siri. Hey, Siri. Who is Yuval Harari?
Yuval Noah Harari is an Israeli historian and a professor in the Department of History at the Hebrew University of Jerusalem. Do you want me to keep reading?
Yes, please.
He is the author of the popular science bestsellers Sapiens, A Brief History of Humankind, Homo Deus, A Brief History of Tomorrow, and 21 Lessons for the 21st Century. His writings examine free will, consciousness, and intelligence.
Thank you, Siri. I saw a couple of interviews with him. And in one of the interviews that is not available to the general public who speak English because it was conducted in English, but by a very famous journalist from Russia who speaks English like a typical New Yorker, grew up in New York. Harari speaks quite a bit about the fact, and he always, says it's a fact. Maybe it is, maybe it isn't. That actually it's almost impossible for people of today to make independent decisions. Like, yes, we decide to buy, when we are in the store, a particular brand of cereal, but it's been processed with us on multiple occasions, whether we are conscious about that or not, by the media, the advertisement, basically major companies influencing our decision making. So he says that at the end, on very few occasions, people really make completely independent decisions. And I can tell you, anybody who is married, whether it's a heterosexual or gay marriage, knows that one of the spouses usually dictates what's going to happen, right? So is the internet becoming this third person in the family who kind of tells us what to do subliminally, Lily?
So I would make the argument that the idea of a purely independent decision is probably somewhat absurd.
Yes.
And so you can't make a decision you can't do anything ignorant of your previous history. You live in a world, you have what we call in computer science state.
Right.
and you accumulate this state through input. And a great example, so we'll go back to reinforcement learning.
Right.
One very common reinforcement learning model is called SARSA, state, action, reward, state, action.
Mhm.
And so the way it works is the agent observes the world around it, and that can include history.
The agent would be a human being.
In this case, it would be a human
Right.
being, or it could be
A cat.
anything,
Right.
or even a program. So in
Right.
reinforcement learning, we train programs
Right.
using the same method.
Right.
They choose an action, and then they receive some kind of reward for that action, either positive or negative. Something happens.
So either reward or punishment.
Exactly. And something changes. And
Right.
so now you have a new state.
Right.
In this case, you went out, you bought the box of cereal,
Right.
and now you've eaten the box of cereal.
Right.
So there's one less box of cereal. State of the world has changed. The state of the agent has changed. You're not as hungry anymore.
Right.
And you've had some reward. You enjoyed that box of cereal, but you also lost some money. So
Right.
you've had this, and your state is constantly building up over time, and you're influenced by all of these chain of actions that have gone on. But the introduction of the internet doesn't necessarily change the way that human beings function, the way that any intelligent agent functions in that model. You're getting more information in, maybe,
Right.
but arguably, it's not necessarily more information. If we go back to computer vision, there's a certain, what we call bandwidth or bit rate for every sensor.
Right.
The sensor can only receive so many bits per second.
Right.
Our eyes and our ears and our senses can only receive so many bits of information per second, no matter what's going on around us.
Which is quite a bit, no pun intended.
Absolutely. Quite a bit.
Quite a bit.
Tremendous amount.
Right.
But what the content of that information may change over time as we read new books, we experience new things. But the fact is, we see the same amount of color, the same amount of light. We take in the same raw amount of information.
Right.
Now we have this new information that we're getting from the internet, from the advertisements, but advertisements have been with us in an ambient form for probably near on a century now, between radio, television, print, billboards. This isn't a new phenomenon for humanity. We have
Yes.
been getting bombarded with ads constantly. And the fact is, I would make the qualitative argument now that the significance of the information, or the signal versus the noise in the information streams, has probably declined somewhat, at least in the last 10 years, so that we're not even making sense of a lot of it. It's just noise.
Well, Harari actually says that what is very different is this. Before you had billboards, you had TV, or as example, he gives, for example, Hitler speaking to the crowd, or let's say Lenin or Stalin or whoever, it doesn't really matter. So speaking to the crowd without being able to identify an individual user. Or you take a TV commercial, for example, everybody's watching it. So what is happening now, says Harari, is that now they can target an individual and tailor advertisements to a particular person, depending on what this person's characteristics are, and they are continuously gathering information. And if before, even KGB and CIA and Mossad could gather the information, but didn't have the resources to process it, now they can, because computers do it, right? So it's actually individualized, more effective, more intrusive, says Harari.
Again, I would disagree with Harari on this.
Okay.
So
That's totally fine.
we've been tailoring information to the audience for as long as we've had broadcast media. The first instance of segmentation is the introduction of channels on AM radio or FM
Right.
radio. And as soon as you have additional stations, you have de facto audience segmentation. Some people listen to classical, some people listen to country.
Right.
So while you can't individually target,
Right,
you can target two broad groups.
right.
But
But
as
now he says you can target an individual.
But hold on. So radio stations also don't have infinite range. So
Right.
now you can choose by geographics.
Right,
So you can start to choose by more and more fine-grained characteristics. With the advent of television, we had even more channels. And I used to work for a magazine company, and I can tell you that with the advent of magazines, custom advertising in magazines targeting very, very small population segments, like custom printed runs, has
Right.
been possible for 30 or 40 years. So I would argue that Harari is ignorant of the degree to which advertising targeting
right.
has been going on
Before, you mean?
before the internet. And I think he's also vastly overly optimistic about the success today. So I ran advertising for one of the world's largest media companies.
Okay.
And I can tell you that targeting is more of an art than a science still. And more often than not, the demographics being targeted are not you as the individual. It's not effective to produce an ad campaign for an individual person. No company does that.
Right.
What they do is they produce a campaign for a demographic, for a segment. It's not really a tighter segment than it could have been even 50 years ago. They're going to produce a segment because the segment has to appeal to a broad audience. It's not profitable to run. If you say the cost to produce a podcast or an audio ad is $5,000, there's no amount of Glad wrap you can buy that could make it profitable for me to produce an ad for you.
For your information, the minds of the internet, $5,000 is not the price of producing this podcast. It's significantly less. Otherwise, I would have been out of business. I hear loud and clear what you're saying. Just for the sake of the argument, but not just to argue with you, I'll give you an example, very recent example, that really pissed me off. So, I don't know about you guys and the minds of the internet, but to me, modern politics and news, this stuff is very disturbing. So I start my day when I decide, not like immediately when I wake up, but when I decide to check out the news. I go on a kind of progressive Russian website, which is called Echo of Moscow, and read in Russian what's going on. It's kind of more removed. They don't mention American political life that frequently, similarly like we don't mention their life that frequently. And all of a sudden, I'm noticing more and more that while I'm on their website, reading it in Russian, and the website is located somewhere in Russia, in Moscow, the advertisements that they are flashing at me are for psychiatrists, I'm a psychiatrist, in English, talking about salaries of psychiatrists and psychiatric residents, offering me information about psychotropic medications. It's all in English. So this is basically tailored towards me because I'm a person who reads Russian. I live in New York, so they can see it, apparently, right? And I'm a psychiatrist. How the hell do they know I'm a psychiatrist?
I think it's fair to say they're able to build a profile of you over time.
Absolutely. So the
So
number
then
one,
they're targeting me personally. Then Harari is right.
they're not targeting you personally. So the number one ad distribution company in the world is Google, far
Right.
and away. So the way advertising generally works, what the Russian publication is doing is they've outsourced the injection of those ads to Google.
Right.
So Google has no idea what you're reading. They don't actually care, to be completely honest.
Right.
They know who you are. And to be fair, it's not entirely honest that they don't know what you're reading. They'll have some idea of what you're reading, but that's not what the ad is targeted on.
Okay.
That's why the ads are in English, not Russian,
Right.
because they know that your location is America,
Right.
and they know that your primary language on your browser is English,
Right.
because you're probably using Google Chrome at some point.
Of course, only.
So, so you've told them,
Or Safari, actually.
Safari may, but I'm saying if you've ever
Right.
used Chrome, you've specifically told Google,
Right.
I speak English.
Right.
And so now that you've told them you speak English, and
Right.
you're accessing from New York,
Right. And I'm a psychiatrist.
and the last thing they had to infer was that you're a psychiatrist, and that they do from your search history or from other activity. But that is honestly, that's the most interesting part, because my point is the fact that it's in English,
Right.
you told them you speak English.
Right. I hear you. I
The
understand.
fact that it's targeting New York, well, they know that you're accessing the site from New York. And
Right.
in reality, you're accessing a server in California
Right.
from New York, or actually, more honestly, you're almost certainly accessing a server in New Jersey from New York.
Right.
Because Google's not going to route your traffic all over the world. They want to serve very quickly.
Right.
So the ad, and this is the thing, the ad, while it's embedded contextually to you, is not contextual to them. The actual transaction that occurs, as far as Google is concerned, is this guy from New York logged in and wants to see an ad.
My guess would be that probably what they're doing is they are asking themselves, other people who share his similar profile, where he lives, what is their estimation of his profession is, what his previous search history is, what ads did they click on,
Absolutely.
and they use that to decide which ads to send you.
Scary stuff, I have to tell you. By the way, I mean, there are tons of things that I would like to discuss with you. Apparently, the brains of the internet have kind of, myself included, short attention span. So, but we have quite a few minutes left. I also met probably, I don't want to lie, but like a year ago, a person from New York who told me that he goes back and forth between New York City and Israel because he works for a tech company that created a very amazing device. It tells a blind person what it sees. Can you say a few things about it?
Sure. So I've seen a few programs like this, a few applications. They're really impressive. So I don't know the specific device, but
Neither do I. Yeah.
presumably
Right.
what many of these devices do is they use a neural network and a camera, so
Right.
computer vision to pull it in and a neural network to process the scene to create a description. The most rudimentary ones will use an object detector.
I need to stop you because I know what a neural network is, but considering that Elon Musk just recently announced and showed us the first sample of Neuralink, which is 4 by 4 milliliters and gets inserted by the robot under the skull, your neuro thing is not inside of the brain.
No.
It is a kind of a program, right? Can you like explain it a little bit more?
Sure. So a neural network is a type of program that is modeled after what we think human neurons function like.
Electrically.
Right. And there are definitely differences. We don't have the long-standing chemical signals of
course.
hormones.
Of course.
So it's a very rough approximation to the calcium-potassium channels in the human neuron.
Right.
And so it was actually first propagated by Pitts and McCullough back in the 1950s. And they came up with this mathematical idea that said, if one cell activates, if a neuron activates, it can transmit a signal to all of the other neurons that it's connected to, and they can either choose to take that signal in or they can ignore that signal.
Right.
And we call that the weights of the neuron.
Right.
And then if they get enough activation, they can choose to propagate that signal.
Right.
And so that's the very fundamentals of a neural network. There are now much more complicated neural networks. So in that example, you'd use mostly a feed-forward neural network where the signal just propagates in one direction.
Right.
But you can have what are called recurrent neural networks where the signal creates a loop and can propagate through over and over again, and it can keep some kind of state. And inside that, you have just a whole family of neural networks, LSTMs and GRUs, and just really interesting stuff. But we also have what are called convolutional neural networks that are based more closely off the optic nerve.
Right.
And so only neighboring neurons transmit signal forward. So they take small groups, or what we call convolutions, and propagate forward into the next layer of the network.
Again, and when you say neuron, it's in quotes, right? It's
Yes.
actually inside of a device.
And that's the thing, it's not even a physical
Device.
Yep, there's no-
Yeah.
in the most advanced technologies we see today, there are what are called FPGAs or field programmable gate arrays, where the neuron is actually a physical set of switches, but it is still a set of electrical switches.
Right.
But that's the closest you'll ever see them to, well, not ever, but it's the closest today that you can see them to an actual human neuron. No, these are software constructs, strictly abstract. Absolutely.
Right. So, and that's how the device works, right? So does it have anything to do with image recognition that you are working on?
Yeah, so I'll feel this one to relate into. So the most rudimentary ones will use an object detector, which is a type of neural network that looks at a scene and tries to find instances of a small class or a known group of objects. So like you'd say, we have an object detector that's trained to recognize people, paper towels, bottles, cans, tables, chairs, streets, and cars.
Right.
And so then the most rudimentary ones of these software won't tell you much about the relationship between the objects. It'll just tell you if you pointed at something, that's a paper towel, that's a car, that's the street. And so you can even get more rudimentary than that and use just an image classifier. So it would only, instead of localizing it and saying, oh, there's a paper towel roll in the middle, it would say there's a paper towel roll somewhere.
Right.
And so as they become more advanced and you add more layers and more complexity to the architecture, they're able to do much more complex things. Like once you can classify part of the image to say what it is, then you can build a detector that does classification over all parts of the image to say where the things are.
Right.
And then you can build a relationship network that will say, oh, this is a paper towel roll sitting on a table.
Right.
And that's the text description that will be generated in the most advanced versions of these devices so that a blind person can point the smart device at something, any scene, and they'll get some description, again, potentially very vague. I don't want to
Right.
I don't want to oversell here. And again, I don't know the specific company or their
Neither
specific
do I.
technology.
I don't know what it is.
But you'll get some rudimentary description, but even that can be tremendously enabling to people who previously could walk into a room and have literally no idea what's there if they've never been in that room before.
Exactly. I feel especially sorry about people who are blind since they're born. One of the celebrities that everybody knows is Stevie Wonder, who actually was born initially with vision, but something happened. They overdid on oxygen, I think, and kind of burned his eyes.
Oh, really? I had no idea.
When he was very, 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 very little. I'm telling you what I read. I don't know what actually happened. And it would be nice if not only Stevie Wonder, everybody who is blind could see. Do you think it's possible in the foreseeable future? People can hear already. There are cochlear implants.
I would give that an unreserved yes. I think that something like that is possible probably in a 10-year time horizon.
Yeah, so you are not as optimistic as Ray Kurzweil is?
Unfortunately, unlike Ray Kurzweil, I have to actually deliver the software that works. So I'm somewhat less...
I hope he's not listening to this podcast.
It's my experience that these things generally take longer, cost more, and result in much more frustration than the optimists believe.
So that
was sort of my thought, as like Jason said it here first. Hold you to that.
So, guys, we are about to wrap it up. And of course, at least I could have gone talking to you forever, which probably I would be very happy to invite you anytime you invite yourself. Is there anything else that is as burning on your mind as the questions that I had to tell us about what's going on in your world?
No,
without revealing any trade secrets, of course. Because my understanding is that Walmart is competing with Amazon, no?
Absolutely. I mean, I can't speak overly much about what Walmart does.
Right.
But we are absolutely embracing the future of technology and engineering. We have this new the Intelligent Retail Lab, which I'm running AI for. So a little tout for that. If you ever get the chance to head out to Levittown, New York, you can see there's a data center that we've put in. There's hundreds of servers in there, thousands of cameras and sensors that we've outfitted the store with so that we can start to better understand and better serve the customers.
Right. I can tell you that I was actually pleasantly surprised about Walmart, and Walmart is not paying me, unfortunately, anything for saying this. When I was in Florida and we needed to buy something, and then I walk into Walmart. I've never been to Walmart before, seriously, in my life. And not only it's a huge store, it basically had everything, and actually pretty high quality. For example, I use Harry's razors, which is like a fancy schmancy thing, not expensive, and they had them. I thought you can buy them only from Harry's. No, they had them. Like they had anything I wanted, and it was an okay quality. Actually, some of it was good quality.
It's actually one of the biggest challenges we face in computer vision working in Walmart is the vast diversity of products that we have.
Right.
So when we build systems, we actually just presented on one of the systems that I was an architect for, which is, we call it Viper, and it's the visual product recognition system.
Right.
And the biggest challenges in Viper, and there's two. One is the fact that we have so many products. In our store alone in the IRL, we have over 30,000.
What is IRL?
The Intelligent Retail Lab in Levittown.
Okay.
So we have over 30,000 distinct products that we have to be able to disambiguate. And in many cases, those products are very, very similar, either just one size slightly larger, one size slightly smaller. But the second problem we have is that packaging changes all the time.
Yes.
And so if you're trying to visually recognize a box of Wheaties, for example, and they put someone new on the cover, well, you've thrown everything. You've thrown a giant wrench and everything. So we had to devise a system that was really robust, both to the tremendous diversity of products and also to the constant introduction of new packaging. So it has to be almost self-healing, where it can identify, oh, we no longer are able to recognize this. Now we have to figure out what it is.
Yeah.
And it's a really, I mean, in my opinion, and I, again, don't want to toot my own horn here because I kind of was the chief architect on it, but it's a really innovative and novel system. We actually, speaking of Amazon, we were talking at the presentation with some engineers from Zappos, and we're hoping to show some of what we learned and share some of what we learned with them. And so it's, it's relevant to everyone what we work on, and it's not just internal to Walmart. We hope that it can be something that can be brought to the broader community, because even going back to your device we were talking about, where the cutting edge prior to Viper, the state of the art prior to the introduction of Viper, was that these things could only recognize a small number, well, a few hundred or maybe a few thousand objects that they were pre-trained on. Viper really changes the way that that works, and we've pushed the envelope forward, and we're now able to identify potentially billions or trillions of products and constantly update what our beliefs about those products are.
That's amazing. I can tell you, I was sitting at the Italian restaurant in New Jersey, and there was a picture of the wall, and all of us at the table knew that it's a famous picture, but we don't know. We couldn't remember what it was. So one person took an iPhone, opened an Amazon app, and pushed the camera sign, enlarged the visual, and Amazon found this picture. I mean, they were selling this picture, so we could tell what it was. It was mind-boggling. I mean, it's scary stuff.
Yeah, that's part of what Viper does. So we have a similar thing, except we have to be able to identify them in motion and in the suboptimal image.
MG. On this positive note, as always, I'm going to suggest to everybody who listens, including the brains of the internet, keep your brains wide open.
Yeah. Thanks for tuning in to another episode of Brainstorm 9000. If you like us, love us, or marginally tolerate us,
And definitely, if you hate us,
then go on social media and give us a review on Stitcher, iTunes, or YouTube, or wherever you listen to us.
and remember, keep your brains open.